This conference will now be recorded.
Hi, very good morning and good evening, everyone. Welcome back. So last session, we were discussing about the internal components of Kubernetes cluster, right? So we're just going to continue the same thing. And in this session, we're going to continue the same thing. So let's go with where we have done that. Okay. Yeah. So we talked about the importance of a component which is called as etcd. So when you design something, so so we talked about how important the etcd is, right? So and the next very important component is API server. So that is where you're actually all the time you're hitting so through your YAML file. Okay, so you're just hitting that, and so the main component here is API server. So as the previous diagram illustrates us, how important the API server. Everyone will try to contact API server. So that's where the API server maintains, goes with a very critical component in the cluster. So generally, so what if you want to maintain the high available cluster? So again, this is a web service. So that's where you need to have cluster and things like that. So generally, for the high availability of this particular cluster, so what we do is, okay, so what we do is a simple thing. So generally people do is they go with a load balancer. Okay, how does it will be done is, okay, so you're going to have multiple nodes ultimately. So you're going to have another node, and you're going to have another node, like let's say 3 nodes. I mean, it's not a cluster. Like how many nodes you maintain, it doesn't really matter. So previously etcd is a cluster, only one will be active, the others are so kind of supporting that. But now this is an active service, all becomes active. It's a simple web service. Okay, so that's where any client, okay, so who would like to any client who would like to hit this is a kind of okay, so it's a kind of a simple web server load balancing. Okay, so there is nothing specific critical inside this. Okay, but the component is critical, but the setup is not that critical actually. So that's where this is actually going to be a node 1. Okay, okay, so node 1, node 2, node 3, you might be having 3 different API servers. And what we generally do is we can balance the load between those 3 things. Okay, so with a load balancer, so we can balance the load between them. All right, so there it is, or in fact it is written, right? So you basically, so it actually sends the traffic to here, and it sends the traffic to here, it sends the traffic to here. Okay, so all right, and put it to here. All right, and right, so just you can call this as a load balancer. So I mean, so the request will be sent to multiple servers. So that's where you maintain the high availability. Okay, so as a simple web server, right? So you just balance the load. So this is how, and API server API server 1 API server 1 and API server 2, API server 3. Okay, so three servers we might be having, and ultimately you can balance the load this way. Okay, I would suggest this way, this one, and API server share. Okay, copy this. Right, so this is how you're going to put the load balancer concept. All right, and the next one is going to be what API server does. Like, let's say if we'll just talk about the list of tasks that what API server does is it just does the CRUD operations. Like what API server majorly what API server does. So a major API server does is it's talking to the database, right? So API server will always talk to the database. Okay, that's what it does. So API server, it just so sends the data. So that means it's a database, right? Which database it is? etcd database. Okay, it does is etcd database. Okay, so that is where it does the operation. So what are the general operations it does here is it does CRUD, we call it as. Okay, so create. Right, so create and then update. Okay, so it just put like update, delete, and R stands for CRUD operations, or read. Okay, so R stands for read the database, create some entries, and this is all it does. Look, it just does this. Okay, nothing more than that. It all does is just updates the database. Okay, it all does the operations, which is it creates something inside the database, it reads something, it updates, deletes, everything. Okay, so it's done by API server. Okay, so what API server does is API server does CRUD operations. Okay, so here the API server does CRUD operations. Okay, so that's what it is. It's a single point of contact to the database. Like no one will try to talk to the database. Only the API server will try to talk to the database. Okay, so CRUD operations API server. Okay, right. So here it is. All it does is CRUD does the API operation. So this is first thing. What it does is this is one thing it does. All right, and what is the other thing? Okay, so generally, and kubectl also does something like so it I mean, if any client is actually contacting, it checks its authentication, and okay, and it checks its authentication, and it also checks whether it is authorized, and finally sends some information to some controller in the backend. Okay, and okay, this is what generally it does. Okay, so let's try to do some more information here. So generally, along with storing, while storing, generally what it does is also while storing, okay, so it, it it also does the validation. Okay, it also does the validation, but it's a layer actually involved. It also does the validation and also maintain locking on the database database so that no one can modify it. So we already seen this, right? So we already seen this, like yesterday we faced some issue, right? So what is the issue we faced? Can't I change only this much? Mhm. Yeah. So while storing it, it usually does the validation and maintain locking on the database so that no one can modify it. Yesterday we try to go to the database and kind of read the data. It's kind of a binary format, right? So that it only can, it only can kind of decrypt it. Okay, so no one can actually do, it's not storing as a plain text so that anyone can update it. Okay, so that kind of things also it just try to maintain. So while usually doing the CRUD operation, it's not like just simply dumping there. Okay, it does little bit more things. So that's what our understanding is. And also generally the kubectl, what it does is it just goes through different. So kubectl goes with the different things basically. Okay, or sorry, API server goes with different things. But basically, let's say kubectl is a client. Okay, so which we are using any client. In fact, any client. So kubectl is one of them. Right. So and it can be what it does is it just checks the authentication. It just checks the authentication whether you are the right guy or not. Authentication. Okay, it does authentication that it is a right thing or not. And the next thing what it does is it does the authorization. Okay, it also does the authorization. Okay, so it does one by one. So kubectl, all right. So kubectl, whenever you apply something, it just goes with some authentication, whether you're the right guy or not. Okay, and after that it will go with so checking whether you're the right guy to perform it or not. Now let's say I don't have an access to a particular namespace, then it will go and validate whether you have the access or not, kind of thing. So that authorization will do. Okay, and the next thing what it does is it just sends the information to some controller. Okay, not authorization, admission controller. It does. Okay, so what this does again, this also does some job. We'll just go in detail. Just admission controller. Okay, and admission controller, and this actually does some validation, and finally it sends to this also sends it also does some validation, finally your API server, and finally it is going to store it in the database. So it finally goes to the database. Every request you make it, okay, so it has to reach to the database. Even though you give kubectl get pods also, it's a database operation end of the day, right? So it has to hit the database, and that's the reason it's a quite important thing. And I'll go with admission controller. Okay, and it goes to validation, and it goes to etc. Okay, now what each and every phases does, let's take a look. Okay, now okay, so this I can name it as API server flow. Okay, so copy this. Let's put it in a separate page. All right. Okay, so kubectl, there is nothing much to explain. You know the things, but let's go with the next things. Okay, so next things here are give me 1 second, please. Sorry. All right. In the authentication, so generally, okay, so the request coming from client, okay, so client can be validated, okay, can be validated here. So that's what it does. So what it does is the request coming from client is actually going to be just validated, okay. So whether this guy is the right guy or not, okay. So is a kind of a simple validation. So this guy, how it is, how does he do, okay. So that's what he's going to do. All right. So the next thing is actually going to be is and the next thing what he does here is okay. So also one more point actually here, I would put that way. And one more point here, request coming from the client is validated, and it's like kind of, let's put this way, some point just to understand the things, okay. And a request coming from client can be validated, and okay, and the second thing what it does is not does basically, you can also use, you can use more than one authentication. You can use more than one authentication, what we call authentication, so more than one authentication program or software, whatever you call it as, okay. So you can use more than one. It need not be only one, it can be more than one as well, okay. So that means you can maintain one more authentication there. All right. So that is how you can do the things here. So what it does is whether checks you're the right guy or not. That's it. Okay. So probably like, so when you try to log into some websites, they ask you like Google, you log in with Google SSO, you log in with GitHub SSO, something like that, right? So the same way. So this guy also, you can, you can import multiple authentications. Probably might not you do that all the time, but still, okay. So just thinking about the probabilities and possibilities here. Okay, the next thing what it does is it just checks the authorization. So authorization also the same story. It checks multiple things if you have any. So it checks if the request is authorized to perform the action or not. Authorized to perform the action or not, and that's what it is going to check. And okay, it also supports multiple it also supports multiple authorization plugins. You can just understand that way. All right. So this is the thing which it does here. Now the next thing what admission control does, okay, this is fine, and it it forwards the request to admission controller. Now what this guy does actually here, this guy does is something here, which is so it just adds missing data. So if you have any missing data, so you know that all the time you might not be giving all the data, right? So let's say sometimes you're not giving yes service account name, the default is coming automatically, it assigns default. And now let's say image pull policy you are having, if you don't give that, pick up the default value. Okay, so what all the missing data? Okay, so it just tries to add them. Okay, for an example I would say is image pull policy, and second one is service account. Okay, so something like this, you will be having if any piece is missing, automatically it does that. Okay, it just adds some pieces. Okay, that's what is. Or let's say you're creating a replica set where the replicas is missing, there might be some default number, it picks and applies. Okay, so that is where is going to happen. Okay, this one. And finally, okay, so you have given some data, and admission control has given some data, so then all those particular data will be validated. Okay, it will not blindly keep it, it's the proper one or not, it just validate the data. Okay, so whatever the data request is coming from, right, so that particular data it actually validates and finally stores in the database. So this is the whole operation of your API server. The whole operation of your API server is this only. Okay, and it's a quite important thing. So your API server doesn't do anything more than this. It will not bother about creating the pod, it will not bother about okay, adding a node, nothing. Okay, it does all those nothing. Okay, so what it bothers is API server does nothing apart from above operations. Okay, but everyone is connecting to this guy only, right? So that means it's a quite important thing, but everyone is actually connecting to this. Then how it actually manages is okay, so I mean what it does is it just provides the information. So every client reaches to, who are the clients? Not only the kubectl, you have kubelet, you have kubeproxy, you have internal components like control managers, have scheduler, other components, whatever you have seen. All those particular components will try to reach to API server. Okay, we'll try to reach to API server, and it notifies the changes, That's it. Okay, so that's it. The API server does only these two things, nothing more than that. Okay, so yeah, and simple. And even the first point is also nothing. Just API server does nothing apart from the operations, and every client reaches to the API server to note, so, and it notifies the changes. Like let's say I'm giving I am actually asking to get pods, and basically all these layers it goes and touches the database and gets the information and provide it back. That's all it does. Okay, so that's the operation of your API server. Clear? Any questions? Okay, all right. So the next thing which I'm going to do is, okay, so a little bit so just on the second point, basically, I can give some diagram. So here on the second point, so the first point is about those things, and the second point, one more diagram we can make. Okay, so we can just go for any client. So again, no diagram is really needed, but still, yeah. So here just because this and the database gives this. Okay, and here API server, and what is that? Clients. Any clients, and it is here. Okay, simple. So clients, so clients asks for changes. Okay, and clients ask for changes. API server provides the changes, notifies the changes. That's it. Simple. Okay, so that's where okay, so API server does. So now just for your understanding. So the next thing, so that's all. API server role is that much. That's it, nothing more than that. And so the next thing, okay, which comes here is the scheduler. Okay, and the scheduler is also a quite important thing to understand. So the scheduler is the one which creates the pods. Who creates the pod here is the scheduler. Okay, it's a kind of a quite important thing. So the next one is scheduler. Okay, so what scheduler does? Okay, so scheduler also does more or less some job around that, as I mentioned, as we talked about. So what it does is so what scheduler does is okay, so it talks to the scheduler is also one of the client. If you go and read see this particular diagram, yeah. So scheduler is also one of the client to the API server. So it also talks to the API server. So scheduler talks to the API server and scheduler. Okay, and what it does, kind of thing. So scheduler, what it does is, let's see. Okay, so scheduler. So scheduler, and this scheduler is going to talk to the API server. So it talks to the API server. Okay, so and first it talks to API server asking for changes, and this one sends the things. Okay, so notifying the changes. So here, so ask for new pods. Okay, new pod request. Okay, and ask for new pods request on what that scheduler does. And so what it does is okay, so notifies if any. Okay, it gives the output basically. Notification means it's not any technical, basically it just updates. So that's what it does. Simple. Scheduler. Okay, scheduler is going to just schedule the pods. All right, and okay, and again, quite important things here. So just on the working perspective, let's try to talk about one by one. Okay, let's copy and paste this. Okay, so and also scheduler ask the API server for any new pods, and API server response if any. Okay, this is what the continuous polling will happen. Continuous request will happen to the API server. Okay, which is fine. And the second important thing here is okay. So scheduler also will not schedule, and scheduler also will not schedule a pod. Okay, so that's what it is. Or let's put it in a diagram. So if I'm talking about the node, on the node side, who is the responsible guy is a kubelet. Kubelet is the Kubernetes client software which runs on the node. Okay, node side, what is the software it runs is on the right, main software is kubelet. Okay, kubelet is the one which it does. Okay, so that's where let's go here and okay, and I will go with delete. Okay, so let me now delete this. And also, scheduler again will not talk to the node. Scheduler, and it will not directly talk to the node. Okay, so it will not directly, scheduler will not directly talk to the node. The node side software is kubelet. Okay, so the node side software is kubelet, and that is where in between so you have something basically is an API server. Okay, lines, yeah. So it always goes through an API server. Okay, it always go through is an API server, so it will not directly talk. That's a quite important thing. So this is what you have. So scheduler will not ask. Give me 1 second. sorry. So scheduler will not ask a node. That means basically it's a kubelet to schedule a pod. Okay, schedule a pod, and it always go with and always go with and always go through API server. Through API server. And also, if you take a look here, okay, so the previous diagram, if you just go there, and this kubelet is also contacting API server. So this guy will update the information to the API server, and API server stored in the database. And kubelet will come and ask about, hey, so something for me. Then it will pull the information and give it to it. So that's what is gonna happen. Okay, so this is a quite important thing. All right, and now scheduler, what it does then, it just updates. So now what it does, so that's a quite understanding you have to make it now. So the understanding, so that so the scheduler will do now here is, so scheduler, okay, so will update, okay, so which node that so pod should the pod should go with, and it assigns a node name. It assigns a node name to the new request which comes. Okay, so scheduler will update the node that pod should go with. That pod, the scheduler will update which node that pod should go with, and it assigns a node name to the new request which comes. Okay, so the new request which is coming actually just pulls that information, new pod information from API server, and writes a record saying that, hey, node name is this, and just sends back the request. That's what it does. Now while it is sending that, okay, so while it is sending that, so it does not do something super. Okay, so scheduler is not scheduler will not pick a random node, will not basically pick a random node. Scheduler will not pick a random node. All right, so that it is, so scheduler will not just pick a random node just like that. Okay, so from the pool of nodes, what all the nodes you have in the cluster, so attached to the cluster, it's just not just randomly, it will not do some lottery and do that and give it. Okay, it does something. Okay, at the same time, okay, so at the same time, scheduler will not apply any ML techniques. So ML techniques is machine learning techniques. Okay, so it will not super understand the things. Okay, and it will not make it. Okay, so it will, scheduler will not apply any kind of okay, so super machine learning techniques. Okay, and picks the node based on that. Okay, techniques based on that particular one. So this is what it happens. Then, okay, so then scheduler, okay, what it does is it sits in between somewhere, right? So not too much on the left side, not too much on the right side. Scheduler, so scheduler sits in between. Okay, so does in between something that scheduler does. So scheduler does something in between. Okay, So not to very much to the left side, not very much to the right side. So that's where it does something in between. So on the high level, so Kubernetes will do two operations basically. Okay, so what it does is it just okay, so scheduler, it does two operations. It does the two operations they call. It does two operations. So the first one is going to be is the first one could be what filter. Okay, so filter the nodes and get list of nodes. So first thing is it just goes with filtering and it gets the list of nodes. Okay, that's what it does. All right. So what now it does is what is the second thing it does is from the list okay, from the list it applies some what we call it goes with some from the list of nodes whatever it got it. Okay, so from the list of acceptable nodes. Okay, so from the list of acceptable nodes and it has to choose the best one out of that. Okay, so that's what it does. First thing, okay, so it does this, and the second thing is it does this. All right. Okay, so this is what it is going to do. Filter the nodes and get the list of I would say acceptable nodes. So that means some nodes might be in maintenance mode and things like that. You will see, sooner in the next session mostly. Okay, so that's what it does. Okay, so now, okay, so how does it pick the acceptable node? Okay, so how does it pick the acceptable node? I know if I would have done this earlier, I would not waste this much time, but sorry for that. At least I'll make it now. So how does it pick the node? Okay, how does it pick the that particular node? So even though from there you should have an acceptable node, right? Or you should have an acceptable one. So how does it pick it? Okay. So how does it pick acceptable nodes? So there are a couple of things it could does. Okay, so first thing is can node have the enough resources? It look for can node have enough resources, like what all it has, whether the node has enough resources or not. It does check that. And the second thing is okay, so probably any I mean so is node under any pressure. So if you remember, we talked about a concept, so which is labels, right? Taints and tolerations. Kubernetes, it is automatically updating some taints. In the later version, we are seeing some taints. At the ending, if you go to the documentation, you will see that taint nodes by condition. So it also doing something in the backend, right? It is memory pressure, it is disk pressure, it is out of disk, something like this. It updates some taints, and based on that, it's just going. Okay, so but it just looks for is the node is under any pressure. Okay, it can be a disk, it can be a CPU, it can be a memory. Okay, so disk or CPU or memory. Okay, and the third one is actually going to be is okay, in your any node name, okay, node labels are given. Node labels are given in pod. Okay, pod spec. So if any labels are given, okay, like let's say if I go and say that, hey, run on this node, I exclusively tell that, then yeah, so it also consider that as well. Okay, so that is the another thing you do. All right, and whereas whereas the other one is it also look for so if you have given any kind of host ports, so any host ports are any host ports are are given, any host ports are any host ports are given, okay, kind of information is checked. Because host port, if you like to say on one node you open a port number, like let's say you have pod 1 and pod 2, one pod you're opening the 80 port, and the second pod is also running, you're opening the 80 port, which is a host port. So that means it can definitely not run the two pods on the same machine, because on the same host you cannot use the same port, right? So ultimately it has to go to another node. So that's also is another condition it generally looks for. And also based on the volume mounts, okay, so you can go for based on volume mounts. Okay, so if this storage is kind of, if this PVA is available only in this particular node, or if this mount point is available only in this node kind of thing, it just looks that, and the volume mounts is also decides where the node actually should go. And also along with that, something like tails and tolerations, right? Tails and tolerations decide that. And seventh one is so if you have given any pod affinity, so already existing pod and or there, and you want to put near to that, or anti affinity, okay, or anti affinity, okay, and at the same time node affinity and node anti affinities also will come into picture. And so also certain things comes into picture, which is certain things like so pod high availability also comes into picture, and it will decide. So let's say I have a replica set, and I ask for and if I ask for to create a 5 replicas on the cluster, like let's say there are so 5 nodes or 10 nodes, assume 10 nodes you have. So then what it does is it will try to distribute your pods to multi availability zones. Like let's say you go with the cloud, okay, so especially with the cloud basically. So especially with the cloud, now especially with the cloud, what happens, you usually choose multi availability zones, right? So that's where you maintain high, you go with cluster with multi availability zones. The reason is if one availability zone goes down, even it will go with the other availability zone, right? So that is where that kind of sense it does, and based on that it will it will decide. So whatever the reasons is these are the reasons you can consider. These are the reasons you can consider of of what this particular scheduler will consider to so to design a okay, to design to decide basically which node it goes. Clear? Any questions? Boring, too much boring, right? Hopefully people are not sleeping the Friday evening.
No. Yeah.
So the next thing, one more point, like let's say it also does some smarting basically. Okay, so it also even goes with little smartness as well. So for an example, some more smartness it does. Okay, some more smartness that scheduler will use to decide which node to decide. Assume okay, so assume we have two nodes, and assume we have two nodes, and okay, so and first node is having lot of pods, and it has a lot of resources also, in that case it usually it usually try to assume we have assume we have two nodes, and first node is having a lot of pods, and it has a lot of resources as well. Okay, and it has a lot of resources as well. At the same time, in that case, usually it tries to schedule in second node. So if it is a normal cluster, okay, and the same scenario, and second node, if it is a normal cluster, okay, so then assume if it is the same thing, assume you have a two nodes and this one, and now in this case, in that case, it usually try to schedule in first node. Again, if it is a which cluster? Okay, so cloud-based cluster. If it is a cloud-based cluster, so okay, if it is a cloud-based cluster, so cloud, okay, the resources matters, and it can allow you to, okay, it can allow you to release the node and hence save the cost. Okay, so this is what you would do, what it does basically. Okay, so in one case, it's actually going to be the it actually goes with this, and if it is a cloud-based cluster, okay, so if it is a cloud-based cluster and it goes with second node, and if it is a normal cluster, okay, fine, this is what we do. And we do basically it does. So finally, okay, so you can use multi-scheduler. Multi-schedulers in cluster. In a single cluster, you can use multi-scheduler. Always you can specify okay, scheduler name while you do schedule the pod. Okay, so pod scheduler name Kubernetes. Okay, so scheduler name. Okay, here you have two schedulers if you see. Okay, I think is this the one, node critical and cluster critical. Just telling. Yeah, this is the one. This is a scheduler, and okay, it is actually having its own logic and the software which will actually run, or basically it comes from the API. Okay, so that will decide basically. And yeah, so you have node critical and you have system critical, and you go with the pods, and you go with so something basically you have some pod, and if you look for YAML, so what it is actually telling is the scheduler name, scheduler name. So scheduler name is default scheduler. It is taking something default scheduler, so probably okay, so it just picks one of them, okay, whatever it is. So that's how things will happen. Okay, And so that concludes the scheduler. Any questions? Okay. And the last component which is involved over here is controller managers. Okay. There are a lot of okay. So now so far you have seen is so no one is scheduling a pod. Okay. No one is creating a node, or no one is adding a node. Anything. No one is exposing any network. Okay. So no one is creating a volume. But all these operations, who is doing them? Okay. So that's where the controller manager comes into picture. So the name itself generally tells you the controller managers. Okay, so here it is. Controller managers. Okay, a cluster will have a different type of controller managers. Okay, so which of them are you can go with this. So you can go for controller managers and replication manager. So replication manager is the one who maintains the replication, also called as replication replication controller, also you call it as. So this is something which is the one who is responsible for maintaining the replicas. It can be a replica set, it can be a daemon set, whatever it is. The replication when it comes to picture, okay, so the one who actually comes into picture is the replication controller. So this is one thing. And what you have, okay, so replica set, you have a replica set, you have a daemon set, okay, and you have a job controller. Okay, all controllers only, individual controllers, just put it in that one. And you have a deployment controller, so you are actually maintaining some deployments that has a deployment controller. So stateful set, so stateful set controller, node controller to add the nodes and all. Okay, node controller, and you will be having a service controller which opens the service or creates a service and all, and so which actually does this. And these are also the clients, all the clients talks to this one. And endpoint, okay, endpoint controllers, we already seen endpoints, what it is, right? So endpoint controller, and the namespace also, dealing with the namespace is also one controller is there, the namespace controller, PVC controller, like this. So who actually does the work in the actual, who does the work in the backend is, these are the guys actually who does the, who does the work. Okay, so just to give you some context. Okay, any controller, what it does is it just watches the API server. Any controller you take, okay. So any controller, okay, so watches API server, anything, okay, it does watch the API server. So that's what it does, and the API server will tell, okay, hey, you got this, when they go there, it will just tell, okay, you got this, okay. So that's what controller manager. So we don't really need to get into internals, I would say, okay. But just having an understanding, it's a software, it does its job. That's what you just understand. So functional wise, this all it does, so whatever it is, whatever you see, that's what it does, right? So that's what you have. And the next one on the node side component, so which is kubelet. Okay, so kubelet is the one responsible for everything. Okay, so kubelet responsible for so it's responsible for everything running on a worker node, everything running on a worker node. Okay, so this is the one, this one. Okay, so its main job is its job starts with registering a node registering a node in registering a node in Kubernetes cluster. So when you actually add a new node, okay, so the software which you run is kubelet, is the one which goes and so start the things. Okay. So then what it does, as the diagram, last diagram tells, okay, so again watches API server, and okay, so and okay, creates pods, and ultimately basically pod is nothing but a container, right? Just creates a container. So watches API server and create pods. Basically it does. Okay, so when API server tells, hey, you got a new pod, then we will go and do that. Okay, so then it tells to the container, so backend you have a Docker, and it passes to the Docker, and Docker will do that. Okay, so the kubelet continuously monitor these containers and reports their status, events, and resource consumption, everything. Okay, the next thing it does is, so kubelet generally okay, so does monitor the pod status, and sends the report to API server, and API server will store them. Okay, this is what is this one. And so, and also if you remember from the pod perspective, generally if you remember from the pod perspective, so creating this, what we call liveness, like health checks like liveness and readiness are also maintained by kubelet. Okay, so generally this is what the actions it does as far as we concern. Okay, and I think that's fine. Okay, so mostly I don't recall anything else apart from that, so I think that's fine. Okay, so that's the role of your kubelet, and it does. Okay, so I mean, without contacting API server also, it creates some pods and things like that, like, so kubelet itself is a pod, so the other components like kubeproxy is a pod. Okay, so some static pods it can just run. Okay, from that as well. So this is the other thing that kubelet does. Okay, and okay, so basically, okay, the next thing which we have is a service proxy. Okay, kubeproxy. Okay, so it's a kubeproxy, and why it is called as proxy, by the way? All right, why it is called as proxy? All right, so the name itself is telling. Okay, so if you remember the network node port concept, when I talked about the node port concept. Now, when you open a node port, irrespective of which node that pod is running, on every node that port will be open, right? Who does that? kubeproxy will does that. kubeproxy will do that. Okay, so that's where it majorly deals with okay, kubeproxy. So kubeproxy, it majorly deals with IP tables and okay, so and redirect traffic to appropriate, so appropriate pods, okay, or containers, whatever it is. Okay, this is what it generally does majorly. Okay, this is the quite important concept about the queue proxy. Okay, so I mean, in general, this is the major thing of what it does. Okay. So, yeah. And anyhow, the other part actually we no need to talk about, which is a Docker. Okay, so container runtime, which is a Docker. These are the components which are involved in Kubernetes cluster. Okay, so now whenever you set up your cluster, so you have to consider all these components and you have to design your architecture. Okay, so yeah, and network is one thing. One more thing which you have, I think you can talk it in the next session. While designing our cluster, we'll design our cluster, we'll set up our cluster, we'll manage our cluster, and we'll move on to the next part of the syllabus, which is Helm charts. Okay, I think that's all from my side for today. Any questions?
No, Raghu. So this networking part along with chat we will be discussing.
Yeah, the network is nothing but which plugin to use. Okay, based on what scenarios we generally consider. Hardly we have, I mean, you have so many plugins, but widely used plugins are, I think, three majorly. So we'll just talk about, one scenario which we will go with. Okay, so just some glimpse on that, and then we'll move on. Yeah.
Okay.
Sir, one doubt, sir.
Okay.
Yes, Sudhir.
Sir, what is REST HTTP service?
What is that? What is
REST HTTP service.
REST HTTP service is basically REST API, you can call it, not HTTP. It's a REST API service. Okay. So, but what to tell? You need to understand a little bit on the HTTP layer, right? So, REST API. So, what is REST API is okay. So you have to read about that basically. Okay, represental. What is this telling? REST means. So representational state transfer. Okay, I don't know exactly what to say. Generally, yeah, this diagram can help you in understanding something. Is this? Yeah. So if you're actually performing any get, post, put, delete on the, I mean, by sending some data which is in the form of JSON, generally you call that particular one is called as, or it generally does by API server. Okay, it's a web server by the way. You just hit API and get the response. At end of the day, it has HTTP response like get, post, put and put and delete. Those particular operations, but it goes on a very lightweight. That's what I would say. It's a very lightweight, okay, lightweight HTTP call which happens to the server. Okay, so that's it. Nothing more than that. And if you want to have some different types of APIs, you have this. Right, so I can go with the console API server, AWS. API gateway. That's what I'm thinking. API gateway AWS. If you go there, so generally it tells you what are the different types of REST APIs which are available, and this guy will support all those. If you go to try to create something, it shows in a better way. Yeah, HTTP API, WebSocket API, and REST API. And the REST API, this is private, this is okay. And so here it is. I think you asked this one, API, HTTP API. So what this is telling is, so build a low latency and cost effective REST APIs with built-in features such as OIDC and WAUth2 and something like that. But whereas REST API is develop a REST API where you gain the complete control over the REST and response along with the API management capabilities. Okay, so this is pure. This is something like, you know, so HTTP API is something you go for web layer. Even the course is given. Okay, so I think cross something is there. Okay, so it's a DNS level thing. So it's mostly like, you know, so for your web protocols, and this is purely for you know, command line protocols. You just understand that. Internally, how to tell, I'm not sure, but both are same end of the day. Both are same. So based on some features, they are categorizing. That's it. End of the day, it is just an HTTP call. You open on the browser rather than on the browser. You do it on the command line. That's where it's a lightweight and it becomes much faster. Okay. So think about the load of the API server. You're seeing the Kubernetes, right? So that much load, every component is contacting that, and you don't see a latency as well, right? You create a pod, you get it. Okay, you will never see that, you know, it is going, these many components are running in backend. Okay, and it is able to handle them. Okay, how it is because of its lightweight capabilities, basically. Yeah, that's what I would say.
It is like responding, like giving response in the HTTP hypertext formats.
No, hypertext format is not the idea. Okay, so you get usually a plain text, usually in the JSON format. Generally preferred is JSON. So that's where you take Ansible, you get JSON output format, and Kubernetes also will try to give you in the backend complete it with JSON. Okay, so why? Because these are all uses REST APIs. Yeah.
Thank you, sir.
Yeah. Any other questions? Okay, all right. If no questions, we'll meet on Monday and we'll go and design our own cluster. So considering the, you know, so different scenarios. Okay, and we'll design that. Okay, thank you. See you tomorrow. Bye. Good day. Good night.